Hey, welcome my office hours people who are looking for a little extra credit. We got a nice little challenge for you today. We just have to learn how to do these two proofs, okay? So take careful notes and that'll help you in a minute. So the first proof, it tells us the given is AE bisects BD and angle A is congruent to angle E. But remember, before we mark anything from the givens, we mark either one of two things, vertical angles or reflexive property. In this case, you'll see that we have vertical angles present. So we'd mark angle ACB and angle DCE, right? Those are vertical angles. And I'll even label that for you. Those are what vertical angles look like, vertical angles, okay? Now, the next easy thing to mark would be that angle A is congruent to angle E, which we have right here. And then it says that AE bisects BD. So you got to think of it this way. AE is your ax, right? That's what's cutting, and we're going to be cutting in half BD. So if BD, this line right here, gets cut into two parts, what it does is that it gets cut into CD and BC. That would be the two parts it's split into. So looking at this now, we say, okay, our two triangles are congruent. This is AAS congruence. So let's go into writing our proof. Okay. And here we go. Our statements and our reasons. So our first step is to write down our givens. So it says that AE bisects BD. All right, how do we know that? That was a given. Number two, it says that angle A is congruent to angle E. We know that because it is given. The third thing we know is that, well, let's talk about our vertical angles, right? We marked vertical angles. So remember, all proof is writing down what you marked. So we marked the vertical angles. We haven't stated that in our proof yet. We said that angle ACB is congruent to angle BCA. That is so wrong. Don't write that second part down because I just said the same angle twice. How ridiculous, Siegel. That is congruent to DCE, right? Those are these two angles over our vertical angles. Now, the reason is vertical angles are always congruent. Our fourth thing that we haven't mentioned is we never said that DC is congruent to BC. Now, how do I know those two lines were congruent? Well, that goes back to the bisector, right? So since AE bisected BD, I know that they are congruent. So the reason I know this is that a segment bisector divides a line in two congruent parts. Okay, now that we've actually said everything that we need in our proof, we've discussed everything, we can go straight down to our final conclusion, which is we're trying to prove angle ABC is congruent to angle EDC, and we knew that because of angle side congruence. Awesome. Our first proof's done. Let's move on to our second proof. Second proof is one from your test. All right, it's the same thing. In this case, it tells us that BD bisects angle ABC and BD is perpendicular to AC. Now, once again, the first thing we're going to do is we're going to mark either vertical angles or the reflexive property. Do we see those here? And I do. I see the reflexive property. That's when two triangles share a side. So we'll mark BD because it's part of both triangles. Next, we'll mark the first given that line BD, which is your ax, is cutting in half angle ABC. So if angle ABC gets cut in half, it gets split into these two angles right here, because that is angle ABC. It got cut into two by BD, the ax. The last thing is that BD and AC are perpendicular, so we can mark this right here. Okay, now that we've got all marked, we have ASA congruence, and since we're proving parts right here, we know we're going to end this with CPCTC. We're going to, once again, write our proof. We got our statements, and we got our reasons. Statement number one. Let me zoom in a little. We're going to write our givens. BD bisects angle ABC. How do I know that? It's given. 2. BD is perpendicular to AC. How do I know that? It's also given. All right, let's start writing out the things that we haven't actually said that we marked. So we marked that BD was congruent to BD, right? That's the side that they both share. We know that because it is the reflexive property. Good. Now the second thing we could say, or sorry, the fourth thing we could say is angle CBD is congruent to angle DBA. The reason we know that is because of an angle bisector. This one's an angle bisector. Divides an angle in two congruent parts. 5. Now we'll go into the right angles. And remember, right angles, this needs 2 steps. So the first step is going to say that angle CDB and angle ADB are right angles. So first we know the right angles. How do we know that? It's because perpendicular lines form right angles. Now that we know they're right angles, we're going to say angle CDB is congruent to angle ADB. How did I know that? Because of all right angles being congruent. Number 7, now that we've mentioned everything in our proof, like literally everything that we marked, we have there, we could say that triangle CDB is congruent to triangle ADB because of angle side angle congruence. And then finally, our last step, what we're trying to prove, this went off the charts here, AB is congruent to CD because of CPCTC. All right, guys, make sure you can do these 2 proofs. You can practice, and then you got a little quiz on this for some extra credit. I'm already proud of you. Now, the big thing is to make your mama proud so you can give her a kiss when you get home and look her in the eye and say, thank you for everything you do to me, mama. I love you so much. And then you pet a cat, and then you high-five the cat, and then you adopt the cat. Bye.